or train and build the models that you're working on. We take a notebook-centric approach where if you're familiar to Jupyter Notebook, or if you're familiar to the Apache Zeppelin project, Zepl was actually started and founded by the creators of the Apache Zeppelin project. So we understand that the notebook problem very intimately, and that's the reason why we're taking this notebook-centric approach. It allows for iteration, experimentation very, very fast. And then once you start adding collaborative elements like being able to leave chat or comments right in line, or being able to run anyone's notebook or schedule those to run, you start really having a strong case for using notebooks to do a lot of the work that you're doing. Now, the second component is the compute. And we see this is where a lot of data science teams get stuck because they will run into a few problems. One, they'll run into problems in terms of scale. So how do you support a growing team that maybe is used to using a shared server, but now there's too many jobs that are running and they're being queued, or if someone's job fails, it impacts the rest of the team's work for the rest of the day. And by the way, that team member whose job it fails is now the most knowledgeable person in your Linux backend or your operating system backend, is going to be responsible for trying to fix the shared environment that you're working in. Not to mention, there's a lot of other frameworks, compute frameworks like Spark, which are great for scaling, and Zepl has those built in, but they can be very complex and hard to run. So making decisions when you're in data science, if you're going to run your own or manage your own compute, whether it's on a cloud service or locally, there's a lot of decisions you have to make. Like, are you going to have a shared or a dedicated resource environment for each individual? If you have a dedicated environment, how do you scale that for each individual? Are you going to run containers, or are you going to run clusters? How do you make sure that everyone has the same languages, packages, operating system support? And then how do you make sure that this is done securely? All of these questions are things that when data science teams are getting starting out, they're going to start to ask, or they'll start to evolve and mature and maybe start looking towards the cloud for someone else to manage a lot of these questions. And the last bullet I had on other compute is around monitoring and billing. Maybe this is more for the management of the team, but thinking about, if your team is spinning up resources in a cloud service, how do you make sure that you can monitor that and effectively track or limit the amount of spend on those resources? And then lastly, you want to make sure that all of the integrations that you have with other systems or other technologies that you work with are built out. So those could be things around data or the code repos that you work with. And then lastly is the delivery model. Things like, how do we generate reports and dashboards and make sure that those are delivered on time? Maybe they're scheduled, maybe they're we need some sort of app link sharing in order to deliver those. And then of course, if you're building models, you need a way to track and deploy those. All right, so the three main topics that we hear a lot when we're talking about data science in the cloud: code environments, compute, and integration and delivery. And I'm going to talk to you now about Zepl's approach and what that looks like, how we've built out our solution. Okay. So I got my pointer up here to make it easier to follow where I'm talking about, because there is a lot going on here. But you'll see a lot of the same themes that I just talked about in our solution, in our tech stack. So I'm actually going to start in the middle, or the middle here, and talk about the user interface or the unified experience that I'm going to be showing you and demoing in Zepl. All of the work that your users are going to be doing start with the data science notebook, or the Zepl notebook. And we built this to be able to support 3 major programming languages that are commonly used in data science: Python, Spark, and R. And then we've built on, some other nice to have features like being able to run SQL directly inside the notebooks. So maybe for some of the folks on your team or your data science group is maybe one or two, and you're just starting out with these new programming languages, but you're familiar with SQL and just basic, query language, you can use that in Zepl as you get started. Now, the data science notebook is nice, and people are probably very familiar with that. But some of the features that we've built into the notebook that make it an exceptional experience to work with is around a built-in visualization editor to make it really easy to point and click and actually build out graphs and charts to make them standardized, but also fast to deliver. So you don't have to write 10, 20, 30 lines of code just to create a bar chart. We've built in version control into the notebook so that you can always roll back. You can see what changes were made, and very commonly data science teams will use Git or GitHub to version their notebooks, and that works. It works really well to take snapshots of the code, but it doesn't do a great job of taking snapshots of all the output of each paragraph and the graphs that get generated and when those change. So Zepl version control tracks both code changes as well as the reports that are the output of each paragraph. We built in a scheduler. I think this is probably our most underrated feature because once you get your notebook to a point where it's ready to be scheduled or run an update, maybe you're doing a batch process where you're updating data or you're cleaning data within inside the notebook, you can set this up really easily all within inside of Zepl. You don't have to change any code or do any command line configurations. It's all built in, and then you can track the status of each run. And then a new feature we just rolled out is called code snippets. And this will help you take a paragraph of code, save it, and then you reuse that across all of your notebooks. It can be a really nice way to bring on new users and educate them about some of the fundamentals of the languages they're using or the data sources or the data that might be used in Zepl. Right, so that's the notebook, the code environment. You can see everything I'm going to be showing you is built through the user interface. We also have APIs that you can interact with the notebooks that you're building. And then as we go down the stack, we've put a lot of thought into managed compute or managed cloud infrastructure. So the idea here is that each notebook that you run, you're going to get a dedicated container or a dedicated cluster just for the analysis of that one notebook. It's dedicated for the user, and it's not shared. And so the reason why we take this approach is because one, you're guaranteed the resources, and two, if it fails gracefully and doesn't impact other users. And then the images that we've built out is a way to make it really easy for users to interact with all the same packages and dependencies for the operating system that's running, as well as the language, Python, Spark, or R that you're working with. So you don't have to change any code. All you have to do is build these images and attach them to your notebook and then run your code. And lastly, we've down the middle here, we focused on security. So for some of the larger enterprises, it's extremely important to set up single sign-on, either to govern access to data or govern access to the cloud environment. And then also we've set up access controls. So security policies on who can configure what, like who can create data sources or delete them in Zepl. And then you also have the ability to share notebooks with each other so that you can do things like clone or copy other notebooks or run someone else's notebook. Say, for example, they're out of town, they go on vacation, or their computer crashes or something, and they need someone else to access their notebook. You can enable run for other users. And then, of course, we've built user tracking and audit capabilities. So those are the three major components of the Zepl solution: the user experience in the Zepl notebook, the managed cloud compute infrastructure, which really abstracts away all of the nitty gritty of having to run your own cloud or compute nodes, and also built on a very secure platform with access controls built in. Now, I heard some noise. Was there a question? And if you have a question, feel free to drop that into the chat window. Okay. Awesome. So let's go ahead and dive into the actual demo and lab of this of this meeting here. So the first thing I'm going to do is talk to you guys about where the data is coming from and how we maintain it. It's free. It's available to anyone. I'm going to then run through a forecasting analysis that I've built out, show you guys the actual the notebook experience. We'll make a prediction, and then we can and then we'll talk about where do you go next? How do you actually deploy it, and share that with other people? And along the way, we'll talk about the different components of the actual platform. Awesome. All right. So for those of you who don't have Snowflake, don't get hung up that we're starting with Snowflake. Keep in mind that we can work with any other cloud data warehouse or blob or file storage that you might be working with. S3, Azure, GCP, any of the major cloud data sources we can connect to. I'll even show you all the other ones that we have set up. But for our purposes for the demo today, where the data is going to be coming from is actually from the data marketplace. So if you do have Snowflake and you want to get access to this data, you'll create an account and you'll log in to the data marketplace. And once you log in, if I click that, that'll open up a new window here. And we have produced a US stock market data, which has high, low, open, close values for the last 50 years or 40 years. So if you drill down on this, you'll have the option to actually directly import this. I'm logged in as an administrator, but on your screen, you'll see something called request data. You'll click on that, and what will happen is you'll actually clone or copy from that data share, and your database will show up here as the Zepl stock data. And so what we're going to be working with is we'll be using our Zepl Snowflake integration to interface with the stock history table and actually pull that data back for a prediction. Okay, so again, data is on this Snowflake marketplace. You can log in with any account in Snowflake, and then you can request that data. We have some information here to get you started. All right, now on to Zepl. So that's how you can get access to the data we're going to be working with. The Zepl free sign up is here on our website. So if you haven't signed up yet, go ahead and sign up for free. You will click the register page here. I'm already logged in, but you saw it flash. Essentially, you'll put in your business email, and you'll be dropped into a page that looks just like this. Okay, so this is the Zepl interface, and some of the key components here to kind of orient you with what's going on as you're getting started. You'll see that there's a few sample notebooks that we preloaded for you. So feel free to dig around in those and start messing with them. So we have one on TensorFlow. We've got information on getting started. So all the different features that are built in the product, we built a notebook around explaining those. If you are a Snowflake user, we've got Snowflake specific walkthroughs and so forth for the different languages that we support. Okay. All of those notebooks are going to appear in your My Notebook space. This space is private for your user, but as you start to invite new users onto Zepl, the idea is that you can start collaborating on the same notebooks or start cloning and forking other people's work that they've done. You may consider actually creating a new space and calling this the samples and tutorials. And then you can share this space with every single user that's on the platform or in your organization, or potentially a specific user, and give them access to things like maybe just being able to read the notebooks here, or you want to be able to actually clone the notebooks from the tutorial space into their own private space. Okay, you can think of these spaces as shared folders. Essentially that's what they are. But they give you access control and permissions. Okay, if you wanted to build this yourself, or you were using other solutions, there's probably going to be a lot of security access management that has to go into making sure that this level of control is built out. And so we want to make it really simple to start the conversation and start getting the collaborative elements directly into your data science notebooks. And this is where we start in Zepl. All right. So I'm going to share this space. There's no notebooks in it yet, but as we start to add some more, you can either create new notebooks, import notebooks, and that's actually exactly what I'm going to do. I'm going to import a notebook. So I said that all of the things I'm going to be demoing today are actually public and available to anyone. So I have to be true to my word. We talked about the data. The actual notebook that we're going to be running through, I have committed to my my personal Git repo, and it's going to be here under stock forecasting demo. What I'm going to do is you could either download this file, or you could import from the actual raw text from GitHub. So if you were to do that, you can see that our notebooks are just a bunch of JSON. We can go ahead and import and fetch from that URL. Okay, and so we'll follow up with these assets and information after the demo here. All right, so I just imported a notebook that was publicly available on GitHub. You might have some that are local to your machine that you want to import, things that maybe you've been working on in Jupyter Notebook or somewhere else. You can bring those into Zepl. Okay, I actually started this analysis before getting on the phone with you guys, and so I wanted to jump back over here to the notebook that I already have running. Okay, it's the exact same one, but I just had started it before the meeting. All right. So now with inside of the Zepl interface, right, you're going to have the ability to set up and configure all of the cloud resources that you need, and and be able to work with all of those discrete features that I talked about inside of the notebook. So let's start talking about where does the code that you write in these notebooks actually run, right? Because that's the foundation behind one of the core elements of all the data science work that you're doing is where does it run? So inside of each notebook, you'll have a setting for selecting a specific container size. You can see here that I've been running this container, which gives me 8 GB of memory for an hour and 15 minutes about, and it has an idle shutdown time of 60 minutes. So if I don't run anything and I don't interact with this notebook, it'll automatically shut down in 60 minutes. That can be hugely helpful with runaway costs. Let's say that you spin up a resource in AWS or Azure, and you leave it running over the weekend and you forget, and you get a $500 bill or something crazy, come Monday morning. We want to eliminate that altogether. And one way is to automatically shut down these containers. The other way that we help manage those costs is that this container will only run when you actually click the run button on a paragraph or with inside the notebook. So This is a slightly different model than what you're probably used to in a lot of other data science platforms where there are resources that are running 24/7 or behind the scenes, and you can send your notebook jobs to those running resources. Instead of having a shared clustered environment that's always running, the approach we take is that we spin up lightweight containers that are low cost and they only run when you need the notebook to run. Okay. And keep in mind that this is a dedicated amount for the job, and it's guaranteed to be available when you're ready to run. The way that you can configure the settings is right here inside the notebook settings, and you can scale these resources all the way up to 128 gigabytes dedicated memory for this one single notebook. The nice thing about this, and one thing that I've heard from one of our customers recently, is they moved to Snowflake and also started putting a lot of data in S3. And when they made that shift as a team, they stopped having the ability to iterate really quickly on their local device, on their local laptops, where they were doing some Jupyter notebook work, and they needed a solution that was fully managed and easy to get set up, where they wouldn't have to troubleshoot anything on the back end and really be able to support these increased data volumes with their shift to Snowflake in S3. And we see that a lot as data is growing in the cloud, you need to have scalable compute to be able to support that. So this is a really simple way to be able to expand your resources and get a larger container. Okay, so that's where the code runs, right? You might also, if you like to dive down into the specific languages, or maybe you work with a very specific library for things like natural language processing or image processing or something like that, you have the ability to use what we call an image in Zepl, where we'll bundle together all of the about 400 pre-built libraries that are publicly available for Python, R, and Spark. And you can install those all together into a bundled image. There's no command line that's required to do that. So I just want to share really quickly, instead of having to do a whole bunch of install statements on the command line, what we've built is a way to use these images where, and I am logged in as the wrong user, so I won't be able to show you exactly the screen I was hoping to show, but what we do is we give the admins the ability to actually list all of the requirements and all of the libraries and dependencies that they want to bundle together. And then we'll bundle those and package it for you. So it takes all the complexity out of setting up your backend environment path variables and making sure that is replicated across all of your users. Stuff that's doable, but it's quite complex. And if you just want to get started, or maybe you want to share this stuff with less technical people, these images are a really nice way to bundle those libraries together. And you can build different ones. You can see we've got multiple ones here and so forth. Okay. So that's the backend that's going to be running our code, the containerized infrastructure, which is easily scalable, doesn't require any setup on the user side, and you can have it automatically shut down when you want to, and where all the libraries are coming from. Great. So within this stock forecasting analysis, let me start talking to you about what we're gonna, what this use case is and how we're gonna use the data. What we'll do initially is set up our environment. So we have all of our libraries, and we're actually doing, we can do a manual install of a specific library if that's what we want to do to iterate quickly, and then we'll import those libraries. But the next thing is, how do we get access to querying that data, the data from the Snowflake Snowflake database that I showed you earlier? Well, in Zepl, we have a standard way to connect to all data sources. And when I say all data sources, I haven't really explained that yet. What I mean is there are different pre-built connectors that we provide to our users to make these connections secure and to make sure that they're reusable for all of your notebook. And what I've created is a Snowflake data source, which I'll show you in a second. We also have hooks into S3, Alibaba Max Compute, GCP, and SAP and so forth. And then if you want to make API calls to any other data source, we have a way to securely store your API credentials, your username, your password, and access those all within inside of the notebook. And that's called a secret store. So for Snowflake, what I've set up is these parameters. I've got my account name. I have a specific warehouse that I'm specifying, the database I want to connect to, and my public schema, and then the username and the password. So keep in mind that with the approach that we're using here, if I were to share this data or this notebook with Adrian and he wanted to use my Snowflake connector, he would have to also authenticate. So each user has to put in their own credentials, and then that's saved for your user on top of Zepl. And we also support single sign-on to make that even easier if you have multi-factor authentication set up or something like that. Okay. And then from here, when we actually we set up a few user inputs to specify which stock ticker we want to do our analysis on. I selected Amazon. We can set up a start date and a specific model that we want to forecast over. And then we'll run through this code where we can specify a warehouse if we want to, but then actually run a query to bring back that data. What this does is it pushes down the compute to be run on top of Snowflake, so you can still leverage the distributed compute capability that they have to be able to retrieve data very quickly. And then we'll bring back this data in a very familiar format for data scientists into a pandas data frame. Okay. And then I'm showing an example of using the same exact method for connecting, using Spark, using R, or even using SQL directly inside of the notebook. All right, so now that we've got our data connected, we've set up our container to run, let's actually start to visualize and look at this data. So in this example here, I have, let me show you what the code looks like. So in order to generate a visualization in Zepl, you can use all your standard libraries that you're used to, scikit, matplotlib, maybe plotly, or others. If you're using R, maybe you're using ggplot2. We have also built in a visualization function called z.show or show, and you pass a data frame to it, and you're able to make really nice interactive charts all within inside of the notebook here. You can see there's a lot of different charting methods that we have set up. You want to just view the data as a table. Maybe you're just doing some basic sorting and things like that. You want to look at this data to explore it. I've built out a chart using our Plotly editor. So we've built in the Plotly libraries and UI experience into this user interface. And let me show you just quickly how I built this. So I selected first that I wanted to create a bar chart. And then with the data frame that I passed in, selected the specific columns to work with. So I want to make basically a time series chart. So I put the date across the bottom on the x-axis, and I'm charting the open values of the market for a specific day along the y-axis. Then from there, I've also charted the close value along the y-axis and added these labels, which it's all click-through driven, UI driven to be able to edit. You can even pass in variables to these labels. Like if my Amazon ticker changed, I can actually specify the, let's see if I can find it here. You can actually specify some metadata to pass through into your labels inside of the charting editor. So you can make these charts dynamic in that way. All right. So we visualized the data and looked at the stock performance over time. And now I've also charted and produced an overlay here for looking at different moving averages for the actual stock performance. This is something that I like to call out, that once you start building out these graphs, or maybe you're working on different iterations of a model, you might want to leave comments for different users to when you're all interacting with inside of this notebook. So we can leave Adrian a comment. Adrian, please evaluate moving averages. And then if Adrian subscribed or shared with this notebook, he can get a notification, and so you can start to really create a dialogue about what's happening with inside of each different paragraph for your analysis of what you're working on. Okay. So again, lots of different ways to visualize the data using just our show function, and then now we're going to actually create a forecasting model, and there's two different libraries that we could use, or two different approaches that we could use to create this forecast. Let me just check the time. Okay, we're good. The approach that I took was using the Facebook profit algorithm. This is written in Python, which is why my whole notebook is in Python. But we also shared, some other approaches for using Spark and R. Using this library is actually quite simple to get started. So another reason why I took this approach, I think that there's probably a lot of iteration that could happen on top of what I've done. And so before we actually get into talking about the prepared model and the predictions that are made, I want to call out the version control that we have built in. So we can talk about how you might be able to use this to track the model executions or the notebook executions that you have running. You can see from here, right before the demo or this meeting, I created a manual commit or a manual save, so that if I wanted to roll back to anything, I always had that secure net to catch me if I messed up anything. And you can see that we'll render the actual state of the notebook with the code and the output as it was when it ran last during that time, and you can roll back really easily. But then I also want to call out that with inside of the versioning, we're taking snapshots of the code changes that occur, as well as the result set changes that occur. So as your model changes, as you output new, so let me roll back down here, as you get new results from each run, we'll track all of those results here, and then you can always label these different versions with the run or the execution. If you're using any other model tracking APIs or libraries, we can install those or communicate out to other servers. I know that some of our customers use MLflow. They have a server that's set up to track or to log outputs. That's something that we could integrate with, really easily, just using the API functionality. Okay. So once I've actually prepared my data, I'm going to drop a few columns, load in this library, drop a few columns, and then actually pass in the data frame with the value I want to predict on, which is my close value. So I want to see in the future, give me a forecast of what my potential close values would be for a specific date. And then we fit that data using the fit command for this library. And then we can specify, when we want to make our predictions, the actual time frame that we want to predict over. So I said 365 days because that's what I copied and pasted from their documentation. You caught me. But you could really easily change this period to be something maybe a little more relevant, 30 days into the future, or even 7 days into the future. And then we can start to actually predict the prices and store those predictions into a data frame. And that's what I've done here. And then we're visualizing the last 1,000 days of data, again, inside of our using our visualization editor. Okay. One more thing to call out that you might consider as you're working in Zepl is, once you get the either the data filtering or data preparation code built for a specific data set, or you get the model generation code built for a specific data set, you may consider saving those as code snippets or as reusable functions that you can drag and drop or add to any notebook that you might be developing on in the future. And so we have this code snippet a feature here that I'll go ahead and save this and just call this FB Profit model create in Python. And once you save this, in any notebook that you work on, you'll have these to reference, and you can see all the code, you can edit them, and also just selecting this button, you can add them directly into your notebook at the bottom. Okay, so a lot of nice usability features here to make it easier to collaborate and share your experiments and the work that you're doing in the notebooks. All right. Now, the last step of the data science and the modeling process is, what do you do with the results that you get? A lot of times we hear that teams have to give presentations where they need to show the output of their analysis of their notebooks. And so they'll take lots of screenshots and add them to a PowerPoint. If that works for your team, that's great, but we want to provide a lot more ways to actually deliver these notebooks to people that aren't interacting with the code. And so we have a publish feature where you can actually deliver this as a data app just through a URL. And that will be read-only capability. So if someone wants to see the latest run of the graphs or charts of the output of your notebook, you can set that up for them. Here's what that might look like. We have a report view, which makes it really nice to clean up all the code and just show only the reports that you've generated, all still interactive. And then you can publish these notebooks here and send this link to whoever needs to consume this information, and they'll get a live updated report view of all of the output that you've generated for your specific notebook. Okay, so that's one way to kind of get to the end state or take the next step of delivering these results. The other things that you might consider is actually, we might want to write these forecasts back to Snowflake. So we've done we basically, we might take a new subset of data or a new set of data that we just got, and we might want to score it against this model and then write the results of that scoring back into Snowflake. And that's another way that you can take the work that you've done in Zepl and use it elsewhere. The other thing that you might consider doing is taking the model that you built and converting it into a model object using some, either a pickle file, or if you're using other libraries, say like H2O or TensorFlow, there's different ways to save models. So you can easily import them back into Zepl at the start of the next notebook. So you can start passing models between notebooks. One way to do that would be through our blob, any blob storage you might work with. This is an example of using S3. We have an S3 connector that'll make it really easy to connect to S3 and upload any files that you might be using. Okay, so all of that's to say, once you get to the end of the actual coding or the work that you're doing in Zepl, you don't have to have it all stay there or live in Zepl forever, right? We want to integrate and play well with others, and we do that in a lot of different ways. And here's a few examples. Okay. Now the last thing that I want to touch on is the scheduling capabilities. So Once you've gotten to this point, let's say you want to retrain your model to accommodate drift, or you want to do a batch scoring process for new data, what you might do is actually schedule this job or schedule this notebook and have it run every day, every week, every month, or so forth, and set up conditions for it to actually trigger. Okay. And once you do that, there's monitoring capabilities. You can see when it's scheduled to run next, what the status of the run was, whether it completed successfully or not, and so forth. So a lot that you can do that's really easy, just one click scheduling, that does take a lot of time and effort if you're working in other solutions to actually get this to work and do it cost effectively. All right. So I just did a lot of talking, and I hope that that was helpful for you guys. I'm just going to quickly recap what we covered, and then I'll open up the floor. I'll stick around here on the Zoom if there's any questions. We started out the presentation talking about cloud data science and looking at what are the kind of the three major components to consider when you're starting your journey in the data science world, and your team is expanding. You've got your coding environment, you've got your cloud resources that you have to, or your compute resources rather, excuse me, that you have to consider. And then you have to think about what are the integrations or deployment capabilities that you need. And then we dove into the Zepl solution and talked about a specific forecasting use case where we grabbed data from the Snowflake data marketplace. We connected that using the Zepl data source connector, ran that using Python, Spark, R, as well as SQL, did some data visualizations and produced a model. All the while we were tracking, using our version control, any updates, changes, revisions that we made to the notebooks. And finally, we published the notebook, scheduled it to run, and completed the work in the session. So hope that was helpful for everyone. Don't forget to please sign up for a Zepl free trial. This is something that you're interested in. And with that, Adrian, I'll turn it back over to you, and I'm open to answer any questions.
Great. Thank you, Zach. Great job. For anyone who has a question, feel free to unmute yourself. For everyone who attended today, you will receive a pair of free Zepl stock. Thank you. I will be sending follow-up emails. However, if you'd like to get me your best mailing address, feel free to reply back to the email calendar via Google that I sent you, or if you received a LinkedIn message from me, feel free to reply, and I'll make those stocks will go out next week, and we will have a tracking number. Our next hands-on lab will be in March, and we will be looking at doing an exciting March Madness event, and so I will send details out. Again, if you have any questions, feel free to unmute yourself now. Unmute yourself. Great. We'll go ahead and conclude. Within the next business day, we will do a follow-up official with a link to the recording. If you have any questions, feel free to reach out to us. Highly encourage you to sign up for Zepl if you're not a current Zepl user. And for any of our existing customers, if you have any additional questions or need additional training, let us know. We'd be happy to support. Have a great day. Thank you for joining us. Chat later.